now about what's known as the comparison test. So here we have what we're trying to do is compare a series that we're given to a series that we already know what happens to it. So if we already know that, so in case 1, if we know that the series B of n already converges, that means that as they're increasing at a very small amount, and then they don't go to infinity. So they converge to some number. Well, if we have a situation where we have a different series that has ANs instead, and all of the ANs are less than the BNs, then our ANs will converge as well. Or maybe not all of them, but if there exists an integer n such that this is the case for any n greater than or equal to that n. So maybe the first 5 terms, it's not smaller than it, but later on it gets to be smaller than it, and every subsequent one after that it is, then it works. Similarly, if you know already that the series for BNs diverge, and you have the ANs are greater than or equal to said BNs, again at some point n greater than capital N, then your AN is going to diverge as well. And there's a series that's good for this. We know what the P series is, right? We talked about the P series last time. So if you're in a situation where you have, so P series is a sum n equals 1 to infinity of 1 over n to the P. What did we talk about with that? Well, if P is less than or equal to 1, that means series diverges. And if P is strictly greater than 1, that means a series converges. So those are good ones to use for the comparison test because we can usually make other ones look like it. In fact, the 2 situations that I've chosen will be able to compare to a P series. So let's look at 194 specifically. All right, so we're looking for the sum of n equals 1 to infinity of 2 over, I'm going to distribute this, so n squared plus n. That's where we're at, right? Okay. So, first of all, this equals 2 times the sum n equals 1 to infinity, 1 over n squared plus n. The 2 doesn't matter. We can pull the 2 out, and if the series converges, it's going to converge whether or not we multiply it by 2 or not, and it'll diverge. The 2 won't affect that as well. So we're just going to compare specifically 1 over n squared plus n to a similar P series. Well, how does that relate to 1 over n squared? Well, this is a number that's going to be less than or equal to 1 over n squared. Right? Even starting at 1. So if we start at 1, we have on the left 1 over 2, and on the right we have 1 over 1, which is 1. So this is for all n. And integers. Okay, so because we have that, we look at the first rule here. So we're in a situation where our ANs are always less than the BNs. Our BNs will be the 1 over n squared values with n's. So basically, how we would write it up like this, we say that since we can even do this if we want, put the 2 there. For all n, we have that our series converges since the p-series we compared it to also converges. Okay. So now let's take a look at 197. So what p-series is going to look like? This is similar to 1 over n, that series. So 1 over n, so 1 over n to the 1 is going to diverge. So we need to set it up so that it's going to be greater than this for all cases. But if we just compare it to 1 over n, we can't use the correct comparison, right? And why is that? Well, because 1 over 2n minus 1 is actually going to be smaller than 1 over n for most of them, okay? But let's take the series 1 over 2n. Okay, this is equivalent to 1/2 n equals 1 to infinity of 1 over n. And this part diverges. So we've got a 1/2 there, okay? So how we can write r's to get a similar value. So we have 1 over 2n minus 1. That's the same. If we pull out a 1/2, we're going to have 1/2 1 over n minus, we're pulling out a 2 in the denominator, so that's going to be 1/2, right? So what happens? Well, now we're bigger than 1 over n. So we have, let me scroll down. So this is always larger or greater than or equal to our 1/2 n equals 1 to infinity, 1 over n, this guy. So we're always greater than that. So that means since this diverges, so too will this. So we had to play with that one a little bit more to actually use the comparison test. We can't directly compare it to 1 over n without a little bit of nonsense, but hopefully you get the picture.